Okay, guys, welcome to today's post-contest discussion for Codechef Starters. Today, we'll be discussing problems A, B, C, D of Division 2. So, let's get started. So, starting out with the first problem, which is add one or two game. Alice and Bob play a game. There is an integer x, which is initially 0. On their turn, Alice or Bob can choose to either increment x by 1 or 2. The game ends as soon as x greater than equal to n holds. All right. When the game ends, Bob wins if x is equal to n. Otherwise, Alice wins. Alice goes first. The players alternate turns. If both play optimally, predict the winner. Okay, guys. So this is a very interesting problem, and let's try to learn the concept of proving through this problem. Okay. So what does the problem say, guys? Initially, x is equal to 0. First, Alice plays, then Bob plays, then Alice plays, and so on and so forth. All right. On each move, either you can do x plus equal to 1 or x plus equal to 2. The game ends as soon as x is greater than equal to n. At that moment, if x is equal to n, then Bob wins. Otherwise, Alice wins. All right. Is the problem statement clear for everyone, guys? Do let me know in the chat by writing yes. All right. So, guys, there is a very simple proof for this. Okay. So, consider that Alice is going to win. Okay. Alice is going to win. All right. If Alice is going to win, do you agree the last move is made by Alice? All right. If the last move is made by Alice, the first thing that should hold is Alice is in a position x such that x is equal to n, smaller than n, and Alice wants to make x greater than n. Yes or no, guys? Tell me. Yes. Now, does this mean that Alice is on position n minus 1? Why? Because you can only have plus 1 and plus 2. And if Alice wants to make x greater than equal to n, the only position where x is smaller than n and you can have a plus 2 maybe and make it greater than n is n minus 1, correct? Okay. Now, guys, we have already deduced that if Alice is going to win, Alice is on position n minus 1. Okay. So let me just erase everything else. And Alice is on n minus 1. Okay. Now, if Alice is on position n minus 1, guys, do you agree Bob was either on n minus 2 or n minus 3? Yes or no? Yes. Now, guys, if Bob was on n minus 2, instead of going to n minus 1, he could have just done a plus 2 and he could have won the game. Yes or no? Yes. Now, similarly, if Bob was on n minus 3, Bob could have gone to n minus 2. And now Alice can only choose between n minus 1 and n. And if Alice chooses n minus 1, we go to n. And do you see that in both cases we win? Okay. So, guys, can you see that if n minus 2 or n minus 3 are possible indices, basically, if n minus 2 or n minus 3 are greater than equal to 0, then Bob always wins. Yes or no, guys? Because we just proved If Alice were to win, Alice had to be on n-1, which means Bob was either on n-2 or n-3. But if this is the case, at n-2, Bob can directly win. At n-3, also Bob can force a win. There is no other way to reach n-1. Okay. So, guys, if you look at n, all right, if n is equal to 1, Alice starts at x is equal to 0, which is indeed n-1. This is the case where Alice wins. All right. Where does Alice win? Where basically x is equal to 1. At any other case, n is equal to 2, 3, 4, so on and so forth, Bob will always win. Okay, guys? Is this much clear for everyone? Great. So this is how you could prove the correctness of your solution. We have a more or less big O of one solution. Int n, C n, if n is equal to 1, C out Alice, otherwise C out Bob. A very clear explanation and a very clear proof of why our solution works and how we can code it out. Clear for everyone? Great. If this is clear for everyone, let's move on to GCD and XOR. You are given an array A of size n. You can choose the following operations. Okay. Choose the integers L, R, X such that L smaller than equal to R, and both are indices, and you need to choose an X, and you can do one of the following things. For all I from L to R, set either AI to AI XOR X or set AI to GCD AI, comma X. Is this much? And what do we need to find? We need to find the minimum number of operations. Like this is one operation. We need to find the minimum number of operations to make all elements equal to K. Okay. So guys, what does the problem say? This is also a very interesting and casework based problem. So this problem says that you are given an n and you are given a k. Apart from this, you are given n numbers 1, a1, a2, so on and so forth up till an. Okay. In one move, you can do either of these operations. You can choose an x and you can choose an LNR. And for every number in this range, you can either set it to AI is equal to AI XOR X, or you can set it to AI is equal to GCD of AI, comma X. Yes or no, guys? Where X is smaller than 2 raised to 30. So this is one move. We need to find the minimum number of moves to make all elements equal to K. So guys, the first observation that you can see is that, like, how do you build up this solution? Like, if you weren't able to solve this in the contest, how do you go about thinking this? Think about edge cases first, guys, and then try to build up a generic solution. Let's think of a very simple edge case. Okay. What is the edge case? All elements are already equal to K. Okay. Since all elements are already equal to K, do you agree in this case the answer would be 0? Yes? Now, guys, you have thought of this edge case. Now let's think of some similar edge cases. You thought of all elements being equal to K. Now let's think of a case where all elements are equal to some X. Okay? Where all elements are equal to one particular element, do you agree that we can choose capital X is equal to X XOR K and then choose the entire array? This is L, this is R, and XOR each element with this value. Because if you XOR each element with this value, it would become XOR XOR K, and these cancel out. So do you agree? In one move, we are able to make all elements equal to K. Yes or no, guys? In one move, when all elements are same, apart, right? And it's not K, then we can choose any element. We can choose capital X as X or K. We can make all elements equal to K in one move. Okay. Now, this was using the XOR operation. Okay. Now, is it possible that there is an array such that in one move, you can select some X, you can make AI is equal to GCD of AI comma X, and then all elements magically become equal to K. Is this possible? All right. You think about this. You want to do it in one move. Does such array exist such that the GCD, like you can select some particular X, and after applying GCD to all elements, they become equal to K. Okay. So guys, no, Nikunj, no. So guys, yes. Guys, when can GCD be equal to K? For GCD be equal to K, do you agree K should be a divisor of AI? Yes or no? Correct? That is how greatest common divisor is defined, right? So can I say if all elements modulo K is equal to 0, then in one move, I can select capital X equal to K, and then GCD of AI comma K would be equal to K, since AI modulo K is equal to 0. And do you agree this is the only case when in one move we can do this? Okay. Yes. Like there are more edge cases, but I'll get to it. Okay, guys. Now, consider that these two are not really possible. Then what kind of operations do you have in hand? If it is a very random array, okay, we have come across three edge cases. You can either select a XOR, you can select a GCD, and all elements are already equal. Now, guys, consider a random array A1, A2, A3, A4, A5, so on and so forth. All right. We want to make all elements equal to K1, K, 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 so on and so forth. Okay. Do you agree in one move, we can take this elements GCD, comma 1, because any element taken GCD with 1 is equal to 1, yes or no? Yes. And after doing this, do you agree we can just XOR all elements with 1 XOR K? Because all elements become 1, 1, 1, 1, 1, 1, 1, 1. If you XOR them with 1 XOR K, they become K, 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 K. Correct? Yes. So guys, exactly. So guys, the only thing that we notice is we are either going to require 0 moves, or require 1 move, or require 2 moves. All right. Now let's just break this down on what are the cases. Okay. So let's have a look. This is a very general case. So let's just write this down. This is a general case. Okay. You can always get it in 2 moves. Okay. Now, when is it 0? When all elements are equal to K. Yes or no, guys? If all elements are already equal to K, then we can have the answer in 0 moves. Now, to have the answer in 1 move, either we are going to apply the GCD operation, or we are going to apply the XOR operation, correct? So guys, for the GCD operation, do you agree? The only condition we need to satisfy is that the GCD of the array, okay, should be a multiple of k. Basically, all elements, what I'm trying to say is, all elements modulo k should give me 0, correct? Only then, when we take GCD with k, we'll get k. Now for the XOR guys, okay, we saw that all elements should be the same, okay? All elements should be same, all right? But guys, do you agree the array can also be of type, let's say k is equal to 3. Do you agree the array can also be of the type 3, 3, 1, 1, 1, 3? Yes or no? Yes. In this case, it is indeed possible. Let me just remove this from here. Let me just remove this line. All right. Let me erase this line from here. Okay. 1 second, guys. For the XOR, there are some cases that we need to consider. All right. Consider the array 3, 3, 1, 1, 3. And consider the other array 3, 3, 1, 3, 1. Okay. In both these array, guys, the only elements are 1 and 3. But do you agree that here we can select this 1, 1 and we can take x as 2 and make these both 3. But it is not possible to make these two 3 together, because if I select this range, this 3 also gets included. And now if I XOR it with 2, it becomes 3, 1 and 3. Yes or no? All elements should be equal to all elements should be same. Only then can I make their XOR also same. Like when XORed with the same element, it would give me the same element. Am I making sense, guys? Yes. So guys, in the XOR case, the only case we need to handle is that there should be one range and all elements in those one range should be the same. All right. What I'm trying to say is, it is never possible to get this one and this one equal to the same element in one move. Because if I wanted to get this one and this one equal to the same one in the same move, I have to select this particular array and I have to XOR it with a number. Now, if I XOR it with any x, then these elements will give, like 1 and 1 will give some number and 3 will give some other number. Okay. So the only thing we need to see is that there should be one range. Okay, here there are two ranges. Let me just erase this right here. Okay, and let me just write this down. So 3, 3, 1, 3, 1. Guys, do you see here there are two ranges that are not equal to k, and here there is only one consecutive range which is not equal to k. Okay, and now in this one range, all elements are the same. So what are the two conditions? First, there should be one consecutive range, okay, which is not equal to k. It can't be something like this, then it's not possible. And the second condition for this, all the elements in the range should be the same. Only and only then is it possible. Is this clear for everyone, guys? Yes. So if this much is clear for everyone, that is more or less the solution to this particular problem. It involved a lot of casework. And yes, you had to spend time with this problem. Like you cannot force bringing up this solution very quickly. You need to observe quite a lot of things, but that is more or less it. Let me show you how I implemented it. How I implemented it is not the best way probably. Okay. So guys, I am counting the number of ranges. You can do it in any particular way. But what I'm doing is, first of all, I'm in a set. I'm inserting all the elements, and I'm also calculating the GCD of the array. So first of all, and after that from the set, I'm removing k. Do you agree if I insert all elements into my set, and since it contains unique elements, if I remove k and the size of the set is 0, does it mean that all elements were equal to k? Yes. So if s dot size is equal to 0, then I see out 0. Otherwise, just ignore this for the moment. I'm getting to this in one point. Okay. If j modulo k is equal to 0, g modulo k, this means that the GCD of the array modulo k is equal to 0. Guys, this is same as saying, like, let me give you a very quick statement. If all elements are divisible by k, okay, sorry for that, then the GCD will also be divisible by k. Yes or no, guys? This is like an obvious statement. Great. So if all elements are divisible by k, then the GCD will always be also be divisible by k. So I'm calculating the GCD. If GCD is divisible by k, then I print out 1, otherwise I print out 2. Now getting on to this case, how am I calculating if all elements are same and if the number of ranges are 1? Guys, I want to calculate the number of ranges. All right. And if you look at these ranges, 3, 3, 1, 1, 3, 1, 1, 3, 1, okay? And let's say this is 1, okay? Do you agree that this is one range, k is equal to 3 here, okay? This is one range and this is one range, yes or no? Now, this is the first range. So here ai is not equal to k and I is equal to 0, okay? For any other range, you can see that there will exist a number such that ai not equal to k, but ai minus 1 is equal to k. Yes or no? And that is when we can say it is the start of a range. Correct? Yes. So, that is how I counted the number of ranges. So, if ai is equal to k, then continue. Now, this is the case where ai is not equal to k. So here I'm just doing if I is equal to 0 or ai minus 1 is equal to k, then range is plus plus. Since I've inserted everything into a set and I've removed k, do you agree the elements that were not k, not equal to k are remaining in the set, correct? Now, if the largest and smallest element in the set are the same, do you agree all elements apart from k are the same element? So dot begin gives me the smallest element, r begin gives me the largest element. So if all elements are the same and the number of ranges is equal to 1, then I see out 1. That is more or less it for the solution. Like, you can let me know if you have doubts. We can just quickly take it up. The only thing we are doing is taking an input, inserting all elements into the set and calculating GCD, calculating the number of ranges, removing k from the set. If size is 0, you see out 0. Otherwise, if G is module, like K divides G, or there is only one range where all elements are same, then you see out 1. Otherwise, you see out 2. All right. Great. So yes, today's majority questions were based on casework. And if this problem is clear for every single one of y'all, let's move on to the next problem. Okay, guys. The next problem is triangle count. What does triangle count say? Okay. For an array B containing m distinct integers b1, b2, bm, if we define f of b to be the number of distinct integers x, that satisfy the following conditions. All right. If x is greater than equal to 1, there exist two indices I comma j such that it is possible to form a non-degenerate triangle of sides length bi, bj, and x. Okay. Given an array A, we need to find f of A. Okay. Okay. So guys, what are we asked to find? All right, and now let me take up this some test cases as well, which is basically we can take up the third one, uh, 5 to 412. All right, 5 to 412. All right, guys, what are we asked to find? Basically, this question asks, I'm simplifying it to what the question is asking us. The question asks that given an array, we need to find the number of numbers x such that for this x, like I have to count the number of x that are possible, such that for this particular x, I can select, like there exist two integers I and j, such that it is possible to select two of these numbers and then form a triangle with it, non-degenerate triangle. Okay, guys, we need to find the number of x that satisfy this constraint. Is this much clear for everyone? Like this is what the problem asks. Okay, now if you look at this, for the first one, 5 to 4, 5, 6 are possible because you can select 4, 5 or 6 and it would be possible to come up with a triangle. Okay, now guys, the first thing to notice is that when can we actually form a non-degenerate triangle? Okay, so I'll just write this down again as well. It's 5 to 4 and 12. I'll just write this down for reference, 5 to 4 and 12. Okay, so guys, consider you have a triangle. One length is of side A, second is B, third is C. Let's say C is the greatest side. Okay, do you agree C should be smaller than A plus B? This is the only constraint that matters to us. Yes, guys? Like if C is the greatest side, to form a triangle, the constraint C smaller than A plus B should be satisfied. All right? Now, we have to solve for how many numbers can this constraint be satisfied. All right? So, guys, it is actually very like you can also break this down. Like majority of the problems today were break it down into pieces and solve it, and I think this is going to be a very common trend in the future, because these are exactly the kind of problems your AI cannot solve at the moment. So guys, we have to satisfy uh, B smaller than A plus C, where B is the largest side. Okay. Now we have to select an X which satisfies this. Do you agree, guys, that X will either lie on the left hand side or on the right hand side? Yes or no? Basically saying that either X is going to be the largest side of the triangle or X is not going to be the largest side of the triangle, correct? Now, if this much is clear, let me just write it down. X is largest side of triangle. Okay. And here X is not largest side of triangle. Okay. Now, let me write the array down in sorted order. So it was 5, 2, 4, 12. Let me write it down as 2, 4, 5, 12 because sorting it does not really change anything. All right. Let me just write it down. Okay. Now, consider that X is the largest side of the triangle. All right, guys. Let's say X is one of the sides and the second side is, let's say, 2. Okay. Now, guys, if X is the largest side of the triangle, all right, and 2 is the next side, what is the, no, let's consider the other possibility first, then we'll come back to this. I think this is the more complicated case. Let's consider this. X is not the largest side of the triangle. Do you agree if X is not the largest side of the triangle, we need to pick up one more side which is not the largest side of the triangle? Correct? Tell me, guys, like if X is not the largest side of the triangle, we have one of these fixed. So do you agree we have to fix one more side which is not the largest side of the triangle? Okay, so let's do that. If X is not the largest side of the triangle and 2 is also not the largest side of the triangle. So do you agree the largest, like X right here, has to lie, like it has to at least be 4 minus 2 plus 1? Because we have to now find the largest side of the triangle. If X is not, let's say, if let's say X is 2, okay? Do you agree these 2 is 2 plus 2 is 4, and we aren't able to find any element smaller than this range? Yes? Okay. Now, if that much is indeed clear, like X cannot be 2, can X be 3? Yes, X can indeed be 3. Why can X be 3? Because you can notice that if the smallest side is 2 and if I want something that is larger than greater than equal to 2 and I want a larger side as well. So if I select it as 3, I have 2 plus 3 as 5 and now I can select this particular element. Now, if I select 4, you can notice that 2 plus 4 is 6. I can select this particular element as well. More or less for any side, I can pick up this element. Like now, if I even select anything in the range for, let's say, 12 minus 2 plus 1, like if I select X to be 11 also, it works because or even 12, it would work for any number in this range because 12 plus 2 is 14 and 14 is larger than 12. Okay, I think that is a small edge case to this. Like it would not work for something like 7 because let's say X is 7. In that case, it cannot be right. So there are some ranges to which we cannot have the solution. So let me just quickly guide you through what can be the solution and what cannot be the solution. All right. 1 second, guys. Uh, Okay. Yes. So, guys, the first thing to notice here is that we want to select the number which is not the largest side of the triangle. Okay. For this particular element, do you agree we were possible to come up with the values 3, 4, yes or no? If we fix 2 as the smallest side, the second smallest side can be either 3 or 4. In that case, we can pick this up, correct? Like if the largest side is 4. Yes? Tell me, guys. Like, let me just explain this again. If let's say the smallest side is 2 and the largest side is 4, what are the other sides that we can have? No, that is not the case. What are the other sides that we can have? We can have 3, we can have 4. Yes or no? As the second smallest side. All right. Now, if this much is clear, let's fix 4 as our smallest side and let's pick 5 as our smallest side. All right, the largest side. Do you agree the only x we can have is 4 and then 5? Yes or no? For this set. Now, if that is true, do you agree for this set, the only numbers that do satisfy this is does 6 satisfy it? No. Does 7 satisfy it? No. Does 8 satisfy it? Yes. So do you agree I can have the numbers 8, 9, 10, 11, and 12? Yes or no, guys? Yes. Like if the smallest side is 5 and the largest side is 12, then the only numbers that is not the largest side, which is x, that can satisfy this number is 8, 9, 10, 11, and 12. Okay. Do you see there is a gap here, which is 6 and 7, which is not actually possible? Okay. Now, guys, if you look at it, with 5, I was not able to select 6 and 7. Do you agree that with any other number also, I wouldn't be able to select 6 and 7 because any other number which is on the left hand side of 5 is smaller than 5. So 6 and 7, no matter what you do, cannot be selected. Yes or no? Yes? All right. So, how do you come up with the solution? The first thing we want to do is we want to fix the non-largest side. All right. So, non-largest side as x. All right. So, in this particular case, let me just write it down 2, 4, 5, and 12. Okay. Assume that the largest side is 12. If the largest side is 12, I can have like I can have 12, like consider the smallest side is 2. I can have 12, I can have 11, and I can have 10. I can't have 10. I select this as 4. So now I can have 10. Now I can have 9 as well, but I can't have 8. But now I'll select 5, and now I can have 8 as well. Guys, do you see that all numbers that are possible with 2 and 4 are also possible with 5? Because 5 is the larger element. So how large we select the smallest element, that many more numbers would be possible for our x. Correct? So do you agree if I sort the array, if I want to check the numbers that are possible, if I fix 12 as my largest element, I just need to check the numbers which are possible with 5, which is the number before it. Yes or no, guys? Okay. So this is basically a formal proof that if we wanted to fix the largest side in the array and then fix x as the non-largest side, no, it's not the difference of the largest and second largest. When you fix 12 as the largest elements, these are the numbers which are possible, which are from 8 to 12. Okay, let me just write it down. Okay, guys, wait, let me do this. 2, 4, 5, and 12. For these numbers, 8 to 12 is possible. Now let's select 5 as our largest element. Do you agree that all numbers in the range 2 to 5 would be possible to pick up? Because if we select 4 as our smallest element, 4 as one of the non-smallest sides, we can have 2, we can have 3, we can have 4, and we can have 5. Because 2 plus 5 is 6, 2 plus 4 is 6. Yes or no? If we select this as one of the sides of the triangle and this is the largest side, then all these numbers become possible. We can select 2 as a side, 3 as a side, 4 as a side, 5 as a side. Clear for everyone? Okay. If this much is clear for everyone, now can you see if we, let's say we selected 4 as the largest side. Do you agree we can select 3 and we can select 4 as the other side, like as x, and if we select 2, we have nothing because we have nothing before it. Is this much clear for everyone, guys? Like, what happens when 12 is the largest element? These are the numbers possible. What happens when 5 is the largest side? These are the numbers possible. What happens when 4 is the largest side? These are the numbers possible. And what happens when 2 is the largest side? These are the numbers possible. Is this clear for everyone? Yes? Now, if this much is clear for everyone, let's store these sides. All right. 3, 4 is possible, 2, 5 is possible, 8, 12 is possible. Okay. Now, let's see what happens when we have to fix, okay, 2, 4, 2, 4, let's say 5, 12. All right. Now, we are going to select x as the largest element. As the largest element. All right. Now to select x as the largest element, guys, let's select the second largest element. Okay. If 4 is our second largest element, you can agree that we cannot make an triangle from this side. Okay. Now let's select 4 as our second largest element. If 4 is our second largest element, we are basically forced to select 2 as our other element. So what are the possible values of x? We can have 4, we can have 5. Can we have 6 as our largest side, guys? Tell me. No, right? Okay. Now, let's select 5 as our second largest side. Okay. What are the largest sides? What is the size? Like, what are the largest sides possible? We can have 5, we can have 6, we can have 7, we can have 8. Can we have 9? Tell me, guys. We can have 5, we can have 6, we can have 7, we can have 8, but we can't have 9. So 5, 8. Now let's select 12. So here also there is nothing. All right. And for 12, we can have 12, we can have 13, we can have 14, 15, 16. Can we have 17? No. So do you agree 12 to 16 are the numbers possible here? Correct? So you can see that when we didn't select x as our largest side, we were able to come up with these ranges. Okay. And when we did select x as our largest side, we were able to come up with these particular ranges. Okay. Now, the only thing we need to know is the number of unique elements in this ranges. Do you agree the number of these ranges is 2n? Yes or no? Yes. Now, guys, there is a very famous lead code problem which is called merge intervals. Okay. And this is exactly what we have to do. And how to n? Because Nikunj, for each element, we have one range, right? Not number of elements, the number of ranges. So when it's not the largest side, we have n ranges. And when it is the largest side, we have n ranges. Yes or no? Nothing. 4, 5, 5, 8, 12, 16. Okay. Now, we just have to merge these intervals. And then after merging these intervals, we will be able to come up with the numbers that are possible. Now, how do you merge these intervals? Let me just give you a quick look. Let me just show you how. So 3, 4, then we have 2, 5, 8, 12. 2, 5 and 8, 12. All right. Now, how do we merge these? The only thing you have to do is sort them. And if you sort them, it becomes 2, 5, it becomes 3, 4, uh, it becomes 4, 5, right? It becomes 5, 8, all right? It becomes 8, 12, and it becomes 12 to 16, okay? So now you can see that 2 to 5 has been covered, so everything in this range has been covered. And since this is also everything in this range has been covered, now 5 to 8 also has been covered, 8 to 12 also has been covered, and 12 to 16 also has been covered. Basically, all numbers in the range 2 to 16 have been covered. So the number of elements is 16 minus 2 plus 1, which is 15. Yes or no, guys? Tell me. Yes. So this is basically what you have to do. You have to sort these intervals and then you have to merge them. How do you merge them? You look at the second one and then you merge them till here. And once you have merged them till here, this is equivalent to range 2, 8. And then since this is 8 as well, you merge till here. So it is equivalent to 2, 12, and then this is equal to 12. So this entire range is equal to 2, 16. Okay. Now, I'll quickly guide you through the explanation because I messed up in some parts, all right? Like, it wasn't the best explanation, but let me just show you all. Basically, we divide the problem into two parts where x is not the largest side and where x is indeed the largest side. When x is not the largest side, in this particular case, we fix the largest side as AI. So what numbers are possible? If AI is the largest side, let's consider AI minus 1. This is in the sorted array, all right? We have already sorted the array. So AI minus 1 is the largest. So the first, like the number should be larger, like AI plus X should be greater than AI and X should be smaller than equal to AI. So all elements in the range AI minus AI plus 1, comma, okay, uh, sorry, let me just write it down. AI minus 1 plus 1, comma, AI are going to be the numbers which are possible for this AI, yes or no? Basically, we found the largest number which is smaller than AI. After that, AI minus AI minus 1 plus 1 because that is the difference, and plus 1 because we have to make a degenerate triangle. Now, since X is not the largest element, okay, not, that is why the X can only be bounded up to AI. So these are the ranges. Now, when X is indeed the largest range, let's select AI is the element which is not which is the second largest or something like that. So if AI is second largest, AI minus 1 will be, let's say, the third largest. So what are the elements which are possible? X can be from AI to AI plus 1, AI plus AI minus 1, okay, minus 1, correct? Yes or no, guys? Because we have to make a degenerate triangle. So we select the second largest element, which is AI. Let's select the third largest element, which is AI minus 1. So the largest element can be AI plus 1, AI plus 2, so on and so forth, up till AI plus AI minus 1, minus 1. Is this much clear for everyone? Yes? Now, if this much is indeed clear for everyone, that is more or less the solution for this particular problem. Let me show it to you all. So, um, this delta is just AI minus 1. So let me just make this AI minus 1 minus 1, and let me just remove this from here. So guys, basically for every element, what do? We insert the range AI to AI plus AI minus 1 minus 1, because this is the range where X is the largest element. Okay. And here is the case where X is not the largest element. X is not the largest element. So you put all of these elements in a set of ranges, a set of pairs, and after that, what do? You just merge them. This is a very simple code for merging interval, basically counting the number of elements inside after merging them. So you set your left index as 1. Answer is equal to max 0, comma r minus max L, comma left plus 1. And then you set left as maximum of left, comma r plus 1. In the end, you are able to print your answer. This is equivalent to merging intervals and counting the number of elements. Okay. This is equivalent to merging the intervals and counting number of elements in the range. Okay, guys, is this much clear for everyone? The code is relatively simple. You sort the array, you have a set of ranges. After that, you insert for every index the number of possible values which are possible. After that, you merge them and then you print the answer. Okay, great. If this much is clear for everyone, let's move on to the next problem, which is counting winning subarrays. This is actually a very relatively easy problem. Okay. What does the problem say? We call a binary array B of size M winning if it can be converted to the array 1, 1, 1, 1 by repeating the following operations a finite number of times. Pick L to R when number of ones in the subarray is strictly greater than number of zeros, then replace all BI with 1. Given an array A of size N, count the number of winning subarrays of A. Okay. So guys, let's see what the problem says. The problem says that you are given an array. In the array, okay, it's called winning. A subarray in that array is called winning if you can make all these elements equal to 1 by performing this operation. And what is this operation? You select any particular range L to R in your array such that the count of 1 in that array is greater than the count of 0. After that, you set all elements in that range to 1. Okay. By doing some of these operations, if you are able to get all ones, then it is called a winning subarray. We need to count the number of winning subarrays. Okay. Clear for everyone, guys? Tell me. We need to count the number of winning subarrays, correct? Is this clear for everyone? Okay. Yes, yes. After doing one operation, the array will be modified. Yes. Like if the array is 1, 1, 0, 1, 1, if you have something like this, then after performing one operation, the array will be 1, 1, 1, 1. And hence, this is a winning array itself. Like this range is winning. Okay. Also consider if the array is 1, 0, 0, 0, 1, 1, then this is also winning because 1, you can convert, you can select these two, make it 1, 1, 1. Then you can select this thing, make it 1, 1, 1, 1. Like this thing, make it 1, 1, 1, 1. The whole array is made of ones. Okay. Now, guys, what are we tasked with? Okay. We need to find the number of winning subarrays. Now, we need to first find when an subarray is winning. Okay. When a subarray is winning, right? Now, guys, let me show you an example. Consider 1, 0, 0, 1, 0, 0, 1. Consider 1, 1, 0, 0, 0, 0, 0. Consider 1, 0, 1, 0, 0, 0, 0, 0. Okay. Can you win using this particular array? Is this winning? No, because you cannot select any subarray such that the number of ones is greater than the number of zeros. Okay. Is this winning? Yes. Why is this winning, guys? Because you have two consecutive ones. And then if you have two consecutive ones, you can expand on one side, any side. You will get this as 1. Then you can again expand on one side. You will get this as 1. You will get this as 1. You will get this as 1. And you will get this as 1. Okay. So what is the first observation we see? If in our array, we have a 1, 1, then we can say that it is winning. All right. Basically, if you have more than one consecutive ones, then it is winning. Now, consider this. Guys, this is the only edge case which you needed to think of. In 101, you can select this entire thing and now it is equal to 111. Now, do you agree it is equal to the same problem where you have more than one consecutive one? Yes or no, guys? Great. If this much is clear, what are the cases when you can call a array winning? You can call an array winning when it has either 1, 1 in it or it has 1, 0, 1 in it. Do you agree any other case is just an extension of this case? Like if you select 1, 1, 0, 1, 1, 1, 1, again, this is there. You select, you can think of any array. You can think of this, it has this. You can think of 1, 0, 1, 1, 0, 0, 0, 0, 0. It's an extension of this case. So do you agree these are the only two cases you need to think of? Now, if you are able to think of this, we already know that these are the cases which cause an array to be winning. All right. Now we only need to think of how to count. So let me just take an example and show you how we can count. So let's take an example for, let's say, 1, 0, 1, 1, 0, 0. Okay. Let's take this as our example. Okay. Now, guys, and let's have two zeros here as well. Okay. Now, where is the first index where we find one of these two? It is this, correct? Yes or no, guys? Now, tell me one thing, guys. I have to select this. Apart from this, I can select anything over here and I can select anything over here. Yes or no? Yes. So, If this is I plus 1, this is I plus 2. For my left subarray, okay, I have I plus 1 choices. Yes or no? I can select I, or I can select I minus 1, or I can select 0. Basically, if this is index 2, I have 3 choices. Similarly, this is n minus 1, this is n minus 2, this is n minus 3, this is n minus 4. Okay, if this is index n minus 4, I have 4 choices. Can I say if this is index j, then I have n minus j choices, yes or no? Yes. On the right hand side for my right subarray. Okay. So guys, we can select any index from here as my left subarray, like left bound. Any index from here as my right bound. Yes, yes, yes. And no matter what you pick up, this will be a winning subarray. For example, if I select this and if I select this, do you see that this would be a winning subarray? Because it has 101 in it. Yes or no? Like any subarray that contains it would be winning. So how many subarrays are containing this subarray? It is just I plus 1 into n minus j. Is this clear for everyone? Okay. So guys, first of all, let me make this clear. Okay. And let me write down the indices as well. Okay. So we have 0, 1, 2, 3, 4, 5, 6, 7. N is equal to 8 here. Okay. So here we have 3 choices. Okay. And here we have 4 choices. So we have 3 into 4. We have 12 subarrays possible where it is winning. Correct? Now, this is the second place where we have one of these indices. Yes or no, guys? Okay. So I can select any subarray that contains this and it would be winning. Yes or no? Yes. Okay. But we have already seen the subarrays that contained this as a subarray. So do you agree that if I choose my left index as this, or this, it would lead to overcounting because I have already chosen my left indices as this and my right indices already have been chosen as this. Yes or no? Yes. Do you see how it affects to overcounting? Let's say I chose my right index as this and left index as this. This has already been counted here. Correct? So do you agree that I only can select my left indices from here and my right indices can be any of these 3? Yes or no? So I have 3 into 2 choices, which is 6. And these are the only indices that make it winning. So the number of total subarrays that are winning here are 18. Okay? 18 is the answer for this case. So this is basically what you have to do. Now, guys, how do you go about counting it? Okay? Let's say you found the first index I, okay, where it was winning. Do you agree that for wherever the next one is, you can only select the left from I plus 1, yes or no? Basically, for the first choice, you could select this, and this as your left element, as the left bound. But for the next one, you could only select this and this as your left bound. Can I say that we can, if this is I, then we can only choose from I plus 1? Yes or no? So, if this much is clear, we only need to maintain an index called left, which is initially 0, which basically tells us that what is the left index? Like, where do we have to start counting from? So how many choices I have on the left hand side? I have I minus left plus 1 choices. Yes or no? Because let's say we are at index 4, we have 5 choices, but then we don't have 3 choices. Since left here would be 3, can I say I have 4 minus 3 plus 1, which is 2 choices? Yes. So we have I minus left plus 1 choices for the left index, and for the right index, depending upon where this index is, okay, we have n minus j choices. Okay. And after updating this, after counting this, you just set left to I plus 1. Yes or no? Yes. So that is more or less it for the code. It was just a combinatorics counting problem. Let me show you the code. It's very, very simple. So you can see that we have an answer array. We have an array. We have an answer variable. We have an array A. We take an input, and while I is smaller, I comma j, I have initiated an I smaller than an I plus plus. If I plus 1 is smaller than n and ai plus 1 is equal to 2, this is equivalent of ai is equal to 1 and ai plus 1 is equal to 1. Because if both are 1, only then would their sum be equal to 2. Yes or no, guys? Because it's a binary array. So only where their sum can be only 2 when both of them are 1. So if both of them are 1, answer plus equal to I minus j plus 1 plus n minus I plus 1. Okay, because j right here is I plus 1. Then I set my left bound, my j variable represents my left bound, j is equal to I plus 1. Now, if this is not the case, then if I plus 2 is smaller than n and ai plus 1 plus ai plus 2 is equal to 2, this is same as saying that ai is equal to 1, ai plus 1 is equal to 0, and ai plus 2 is equal to 1. Okay. If that is the case, then answer plus equal to a minus j plus 1 into n minus I plus 2. And then j is said to be I plus 1. Apart from this, do you agree that each individual element 1 is also a winning subarray? Like we counted all subarrays which are greater than equal to size 2. But for size 1, all elements which are equal to 1 also are winning. So we just do answer plus the count of elements that are equal to 1. That is more or less it for this problem. You just had to count the number of subarrays that contain 1, 1 and 1, 0, 1. If you look at how to count this, it can just be solved by stopping over counting. Is this much clear for everyone? All right. Thanks a lot for joining in. I hope you learned something today from the post-contest discussion. The problems were relatively hard. They involved many steps, but I hope I was able to do justice to your time and you guys were able to learn something new. If you like the PCD, do make sure to like and subscribe. See you at the next post-contest discussion. Bye bye, guys.